Alrighty, so we're going to look at simultaneous equations today. So this is going to be a nice little kind of brief revision session. So we learned earlier in the year, there's two ways to solve any kind of simultaneous equation. And the first thing before we talk about that, we should talk about what are we finding when we're finding a simultaneous equation. Well, you're looking at the point that where two straight line graphs, for the moment it's just straight line graphs, but you will, as you go further in your maths education, look at other types of graphs or equations as well. Okay, but for the moment we're focusing on two straight line graphs. You're finding where do those two lines meet? Where do they cross over each other? And we call that the point of intersection. The point of intersection, where they're equal to each other. And we have two ways or two strategies of solving that. The first one is what we call substitution. Okay, and that's where we're literally substituting in, replacing one variable with another to reduce the number of variables in an equation. Okay, and we generally tend to use substitution when our equations are written in terms of y and x. So where you have, y equals, we'll say ax plus b, we'll call this one cx plus d. Okay, where you've got it written where y is equal to something with x, we generally use substitution. The other way of solving is using what we call elimination. Okay, and that's where we are adding or subtracting the two equations together to eliminate a variable. Okay, and generally we use this one when our equation's written as ax plus by equals c, and then we'll say dx plus ey equals to f. Okay, so where you've got the x's and the y's on the same side of the equation, and usually they've got some kind of variable in front of them as well. Okay, so that's our little summary of when we would use each type. So the first one we're going to look at is substitution, and then we're going to go into elimination because there's a bit more variation in those. So we've got this first equation, which is y equals 2x plus 1. Okay, gradient 2, y-intercept 1. And the second one, y equals negative x plus 4. So gradient negative 1, y-intercept positive 4. And I'm going to call this one equation 1 and this one equation 2. And I'm going to sub equation 2 into equation 1. And I'm going to do that by replacing the y in equation 1 with the negative x plus 4 in equation 2. And I can do that because I'm trying to find the point where they're equal to each other. So where is equation 2 equal to equation 1? Well, they're equal when those y values are the same, and therefore when 2x plus 1 is equal to negative x plus 4. Okay, so from there, I'm going to add the x and cancel that out. So I'm going to make sure I've got all of my variables on the same side. So that becomes 3x plus 1 equals to 4. Then I'm going to subtract 1. I'm a bit ahead of myself. I'm going to subtract 1 from both sides. I'm left with 3x equals to 3. And then lastly, I'm just going to divide through by 3. And I'm left with x equals 1. Now, I haven't 100% finished this equation because when I'm finding any point of intersection, I'm looking for the coordinates, okay? I want the x and the y coordinate. So I don't only want x, I also want y. So to find y, I'm going to put that 1. I could put it back into either of those and I should get the same answer. But I'm going to put it back into equation 1 because there's no negatives. So y, in this case, is equal to 2 times 1 plus 1, okay, which is 2 plus 1, which equals to 3. Okay, so my point of intersection or my solution is at x equals 1, y equals 3. Okay, Perfect, moving on. Next one. All right, now these three are we're all gonna use elimination for these because they're written with the x and the y on the same side. And therefore, it kind of makes sense to use elimination. So this first one, the things you need to think about with elimination is, do you have variables that have the same coefficient? And then you need to think about, do you need to add or subtract to be able to eliminate those variables? So with this first one, I have 1x plus 1y equals 10, and 1x plus 2y equals 14. So I can see here, both of my x's have the same quantity of those. Okay, so if I subtract these two equations from each other, okay, then x minus x gives me 0. So that's good, so I've gotten rid of the x. Y minus 2y is negative 1y. And remember, when you're doing if you're subtracting one part, you subtract everything, okay? And then 10 minus 14, well, that gives me negative 4. So therefore, minus y equals minus 4. If I divide through by negative 1, cancel that out, I end up with y equals to 4. Right, last thing is I want to find x, so I'm going to sub that y back into that equation 1, so I end up with x plus 4 equals to 10. Okay, minus the 4 off, so x equals to 6, and my solution is at x is 6, y is 4. Okay, second one. Now this one's a little bit different because we can see here we've got 1x plus 3y equals 20, and then 2x plus 1y equals 15. So I don't have the same amount of any of those. So I'm going to have to add in a bit of an extra step here. And the first thing I'm going to do is make one of these equations have the same amount of the x's or the y's. And I do that by multiplying that equation, making sure that I keep everything in the same proportion. So I'm going to times this top equation by 2 to turn that into 2x, but I need to make sure that when I do that, I multiply everything by 2 so that I keep all of the same ratios of the different quantities. I'm just going to change this back into block. This bottom one stays the same, so 2x plus y equals 15. Okay, we go into red for this next bit. So now I've got the same quantity of my x component, and in this case, again, these are both positive, so I'm going to subtract this. So 2x minus 2x is 0. Perfect, that's what I want. 6y minus y is 5y. 40 minus 15, that gives me 25. Okay, therefore y is equal to 25 divided by 5, so that gives me 5 altogether. Now I'm going to sub this back in again, and I'm going to use this bottom equation now. So I've got 2x plus 5 equals to 15. Okay, that means 2x equals to 15 minus 5, which gives me 10. Okay, and x equals to 10 divided by 2, which also gives me 5. Okay, so in this case, my solution is 5, exactly the same. Okay, last one. I'm just going to go down a little bit for this one. Okay, now we've got x minus 5y equals 12 and 2x plus y equals 5. Now, normally I would multiply this one by 2 to make the x's the same amount. But because we've done all of the x's so far, I'm going to do it the other way, and I'm going to make the y's the same value. So in this case, I'm going to times this equation. Oh, sorry, wrong one. Just rub that out. I'm going to multiply my bottom equation by 5, okay, so that my y's are equal. So on the top, I'm left with x minus 5y is equal to 12, and then on the bottom, I'm left with 10x plus 5y equals to 5 times 5, 25 again. Okay, so now my y's are equal, and I have here a positive and a negative of those values. So in this case, instead of subtracting these equations, because if I subtracted them, I'd end up with negative 5 minus another 5, which would give me negative 10, which is not negative 10, which is not what I'm after. What I want is to have 0. So in this case, I'm going to subtract. I'm going to add these equations together because I know -5 plus 5 is going to give me 0. Okay, so here I've got x plus 10x, well that's 11x, minus 5y plus 5y is 0. Okay, and 12 plus 25, that gives me 37. Okay, so 11x equals to 37, and x equals to 37 over 11. Okay, because I'm going to divide that by 11. Okay, now this isn't a nice number, but that's okay because we don't always end up with nice numbers when we're doing simultaneous equations, and you need to get used to that. A lot of the time you will, especially when we're just starting out and going into GCSEs, but when you get up to your A-levels and things like that, you are not always going to have nice values. So next thing we're going to do, I'm going to sub this 37 over 11 back into my top equation, and I'm going to find my answer. So here I've got 37 over 11, that's x, minus 5y equals to 12. Okay, so now take minus 5y equals 12. Now I'm going to subtract off that 37 over 11 on the other side. Cancel that out. So 12 minus 37 over 11. Okay, minus 5y equals 2. Now, I'm going to change this into a fraction over 11. So 11 times 12, 132 over 11. Minus 37 over 11. Okay, negative 5y equals to 132 minus 37. Well, I know 132 minus 32, that would be 100. And minus another 5, that would give me 95 over 11. The last thing I'm going to do is I'm going to divide through by minus 5. Okay, so I've got y equals 95 over 11 divided by negative 5. Now, if you wanted to, you could just tuck this in your calculator and you could work it out. But I'm going to do it a little bit differently. So I know if I'm dividing by, that's negative 5 over 1 as a fraction. And I know if I'm dividing by that, that's the same as timesing by negative 1 over 5, if I flip that fraction and change the sign. Now I also know that 5 goes into 100 20 times, so I know that 5 goes into 95 19 times, so I can cancel down these fractions a little bit, and I can cancel out 5 with 95, that goes 19. Okay, and we get 1 on there on the bottom. So my answer is, I'm just going to keep these pens the same, y equals 19 times negative 1 is negative 19, 11 times 1 is 11, so negative 19 over 11. So my solution for this one is that x is 37 over 11 and y is negative 19 over 11. Okay, there we go.